What's up, ladies and gentlemen? So we are moving on into our triangle congruence section. So in 4.4 we learned about exactly what congruent polygons mean. In 4.5 we learned about triangle congruence using side, 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 and side angle side. So now I'm here to show you three more ways that you can look at triangles and determine if those two triangles are congruent. And so those three ways, 4.6 triangle congruence by ASA, AAS, and HL. And I'm here to tell you and show you exactly what those mean. So the first one we're going to look at is ASA, which of course the A stands for angle, the S stands for side, because that's all that triangles are made up of. So here we go. So let's look at this. So ASA stands for angle, side, angle. And the main thing I want you guys to look at again is the side is in the middle here. So this is going to be known as included again. So that means the congruent side has to be in between the two congruent angles in order for this one to work. Okay? So let's go look at this. Angle, side, angle has two angles, and included side of both triangles are congruent. And so if this happens, then that means both triangles are going to be congruent to each other. So for example, let's go and look at this. So we have triangle GBH and we have triangle KPN right here, ladies and gentlemen. And so what I want you to notice here is on angle G over here, we have two green arcs right here, okay? And over here in K, we have two green arcs here. So right now, ladies and gentlemen, we have one angle that is congruent to each other, okay? And so now let's go over here to the right. On H over here, I have one arc. On N, I have one arc. So that means those two angles are congruent. So ladies and gentlemen, I have my two angles that are congruent. But now here's the kicker. We have to make sure that the side in between those are congruent as well. Let's go ahead and look. In between G and H, side has one notch. In between K and N, the side has one notch. So ladies and gentlemen, the included side is also congruent. So since the two angles are congruent and the side in the middle is congruent as well, that means that these two triangles are indeed congruent to each other. So that means triangle GBH would indeed be congruent to triangle KPN. That's how that works. So the next thing I want to look at is AAS. So again, the A stands for angle, the S stands for side. So in this instance, we have an angle, angle, side. And so by definition, if we look at this, it says, if we have two angles and a corresponding non-included side of both triangles are congruent, then that means that both triangles are indeed congruent. So with this being said, I want you to pay attention to this. Non-included. So remember, included means it's in between. So like my angle, I have my side is included. So that means this side is not included, is not in between those two. Okay? So let's go and look at this example. So down here, I have triangle CDM, and I have triangle XGT right here, ladies and gentlemen. So let's go and look at this. So right now, let's look at angle C. So right now, angle C has one arc on it. Does everybody see that? Okay. Angle X has one arc on it. So ladies and gentlemen, those two angles are congruent to each other, correct? Okay. So now look at angle G. Angle G has two arcs on it. Angle D has two arcs on it. So ladies and gentlemen, these two are congruent. So ladies and gentlemen, angle, so I got one angle. Angle, I got two angles. But now let's make sure the side that is inside these two right here and the side that's in between these two, that's not congruent. But what we notice here is TG has one notch and MD has one notch, and those are going to be congruent. So that is going to be a corresponding side on both of those, and that is congruent. So since I have two angles that are congruent and one side that is corresponding and congruent, that makes these two triangles congruent to each other, ladies and gentlemen. So that means triangle, and I'm going to write it down here so we can see it. So that means triangle CDM is going to be congruent to triangle, and it looks like X, D goes with G, and T goes with M. So ladies and gentlemen, those are going to be congruent to each other, okay? And lastly, I'm going to show you guys about something called hypotenuse leg. That's what HL stands for. And now I want you guys to remember, the hypotenuse and the legs only work with 90-degree triangles, which means a right triangle. This only works with right triangles. So if you have a right triangle, if there's a hypotenuse and a leg of both triangles and they're congruent, then that means that the two triangles are going to be congruent in all, meaning all the angles are congruent and all the sides are congruent. So let's look at this example here. So I have right triangle ABC, and I have right triangle DEF. And so we're going to analyze all this. We already know, since both these are right triangles, that they have right angles, so we don't have to worry about that. But I need the hypotenuse to be congruent, and I need the leg to be congruent. So let's go and look at that. So right now I have the hypotenuse, which is opposite of the right angle, 2 notches. Opposite of the right angle has 2 notches. So is the hypotenuse congruent? Yes. Okay. So now let's look at the leg. So now I have AB has 1 notch, and then over here there's a leg that has 1 notch on it. So that means these 2 sides are going to be congruent as well. So since I have the hypotenuse is congruent, and there's a leg that are congruent to each other, that means both of these triangles are going to be congruent to each other. So that means triangle ABC is going to be congruent to triangle DEF. So ladies and gentlemen, these are 3 new ways that you can look at and analyze triangles and figure out, are the 2 triangles congruent by angle side angle, angle side, and also by hypotenuse leg. All right, so here we go. So right now what I'm trying to do is I am trying to use angle side angle, angle side, or hypotenuse leg to prove if these 2 triangles are going to be congruent. And so right now I'm given some information and I need to prove that these 2 triangles are congruent. So let's go look at this given information. So right now in this given information, angle A is going to be congruent to angle B. So angle A right here is going to be congruent to angle B, okay? And then it also tells us that side AP is going to be congruent to side BP. So side AP right here is going to be congruent to side PB right here, ladies and gentlemen. Okay, so right now I know that I can't do hypotenuse leg because I know that there's not a 90-degree angle. So I know it's either going to be angle side angle or angle side. So right now I know that if I have 2 lines crossing each other, that these 2 angles right here are going to be vertical. So that means they're going to be congruent. So that means these 2 angles right here are going to be congruent. So let's go and look at this. I have angle A up here has 1 notch. I have angle B has 1 notch. So ladies and gentlemen, that's 1 angle. So both of these start out with an angle, okay? So next I see that I have angle here and there's 2 notches on there. So those 2 angles are congruent as well. And now I want you to look here. In between those 2 angles, I have a side that is congruent. So I have angle, side, angle. So ladies and gentlemen, triangle APX would be congruent to triangle BPY because of the angle side angle theorem. So I would put ASA. Alright guys, so here looking at example number 2. So right now what's happening is I need to prove that these 2 triangles right here are going to be congruent by angle side angle, by angle side, or by the hypotenuse leg theorem. So I'm going to try and prove that both of these triangles are going to be congruent. So let's go and look at this. I'm given some information here, and I need to use that information to help me to prove if these triangles are going to be congruent or not. So here we go. So let's look at this. So my given information, I have angle B is going to be congruent to angle D. So right now I'm going to put an arc here, and I'm going to put an arc here. Okay? And so the next thing I'm going to look at is it says side AB is going to be parallel to side CD. So side AB is going to be parallel to DC. So I'm going to draw 2 little arrows here showing that those are going to be parallel to each other. So that's the only information that's given to me. So right now, just by looking at it, I can't prove that these are going to be congruent just by looking at this, okay? So I'm going to have to use some of my prior information that I have already taught you guys to try and figure this out. So right now, we just did an entire lesson over parallel lines and transversals. So I have two parallel lines, and I have a transversal going through them. Does everybody see this? Okay? So right now, I know that this angle right here and this angle right here are going to be alternate interior angles. So they're on opposite sides of my transversal, and they're inside my two parallel lines. So those are going to be alternate interior angles. So those two angles are congruent, okay? And then now also we can see one more thing. If you look, AC and CA inside my triangles are basically going to be the same exact line. So since they are the same exact line, then that means that those are going to be congruent to each other. So this is going to be congruent as well. So now, ladies and gentlemen, do we have enough information to prove that these two triangles are congruent? I'm going to go ahead and say yes. Let's go and look. Side D, or angle D, has one arc. Angle B has one arc, saying they're congruent. Okay? So then if we go across, angle C is congruent to angle A. So look, that's two angles that are congruent. And then I have a side that is not in between those, so not included, that is congruent to each other. AC in this triangle and CA in this triangle are congruent to each other. So ladies and gentlemen, these two triangles are going to be congruent because of the angle-angle-side theorem. So with that being stated, I can now say that everything in these two triangles are congruent. So this angle right here and this angle right here would be congruent. This side and this side would be congruent, and this side and this side would be congruent, because that proves everything is now congruent to each other. Okay. All right, guys, and lastly, I have one more example for the angle side angle and the angle side and hypotenuse leg section. We are going to look at these two triangles, and we are going to determine if these two triangles are congruent by either angle side angle, angle side, or hypotenuse leg. So right now, ladies and gentlemen, as you can see, both of these triangles now have a 90-degree angle. So that means that the hypotenuse leg term has come into play. Now, the triangles can still be congruent by angle side angle or angle side, but since it is a right triangle, then the hypotenuse leg comes into play. Okay, does that make sense? So let's go and look at my given information. So side AB is congruent to side EB, or ED right here. So side BA right here is going to be congruent to side ED over here. Okay? And so now if we look, that's going to be a leg. Okay? And so next, side BC here, so side BC, which is my hypotenuse, is going to be congruent to side EF, which is my hypotenuse. So ladies and gentlemen, by looking at these two triangles, they are right triangles. One leg is congruent to the other leg, and the hypotenuse is congruent to the other hypotenuse. So ladies and gentlemen, triangle ABC would be congruent to triangle DEF because of the hypotenuse leg theorem. Done. It's that simple.